Hi, welcome back. I'm so glad you're here. So yesterday we started chapter 8, which was simplify rational expressions. Today we're moving on in the same packet, available in Canvas, to section 8.2. Today is going to be multiply and divide rational expressions. So just to recap here, just to review with fractions, we would multiply straight across. So you can see here on the top, I have the product of two rational expressions. We just multiply straight across the top, straight across the bottom. If we're doing the quotient, it's the same thing eventually as multiply, because what you do is you keep, change, flip. So what that means is that you keep your first part here, you change the sign from division to multiplication, and then you flip. So C over D becomes D over C. And then at this point, multiply straight across the top, straight across the bottom. If you're interested in another video on why keep, change, flip works, just let me know and I will go ahead and post that for you. Okay, so in this first example here, I have it all written out already. We have x squared minus 4 over 6x minus 42 divided by 5x minus 10 over 3x minus 21. So all I've done so far is keep the first piece, change my sign because it's division, and flip that second element there. Okay, so keep, change, flip. So I wrote what was on the bottom, I wrote up here on the top, and what was up on the top, I wrote here down on the bottom. Then I started breaking it apart. Okay, let me change colors. X squared minus 4 is the difference of squares. So that's x plus 2 times the quantity x minus 2. In 3x minus 21, I'm able to factor out that 3, leaving me with 3 times the quantity x minus 7. On the bottom, I have 6x minus 42. I was able to pull out a 6. And 5x minus 10, pull out that 5. Now at this point, we can go through and see what do we have matching on the top and on the bottom. And we can do that because we have multiply between each of those different parts, right? So if there was any adding and subtracting between the parentheses, we could not cross cancel like this. So we're just looking for matching parts on the top and on the bottom, and that's removing a factor of 1, right? So we have the x minus 7 matches with the x minus 7. And we have an x minus 2 matches with the x minus 2. Just to make it look nice, I pulled the 3 out front and rewrote it as 3 times the quantity x plus 2. On the bottom, I just had 6 times 5 is 30. Might feel like you're done here, but you can actually go one more step just to reduce, because 3 over 30 is the same thing as 1 over 10. That little 1 isn't needed, right? That doesn't make a difference. It's really just x plus 2. So finally, I wrote it as x plus 2 all over 10. All right, so take a look at this first one. We have 5a cubed over 4 times 2 over 5a. So there's a few different ways to do this, and whatever way makes the most sense to you, you can go ahead and stick with. I tend to like to simplify things up front, just so that I don't have a lot of big multiplication and simplifying that I have to do later. So that's just kind of a personal preference. 5, I see this 5 on the top and the 5 on the bottom. So 5 over 5 is really just 1 over 1. The next thing that I'm noticing that I could simplify up front is this a cubed over a. Remember, we subtract our exponents, so one of those a's is going to cancel out, leaving us with the a squared up top, right? And what else do we still have up top? We still have, oh, you know what? Let's do one more simplifying just to make it even easier. Watch this. This 2 over 4. 2 over 4 is really 1/2. So now up top, all we have is just that 1. So I'm not going to worry about writing that in. So we have our a squared. And on the bottom, remember we already reduced this a. So all we have on the bottom is just 2. Okay, pretty cool, right? I'm going to show you a different way to do this, just in case if you didn't like that, if that was too much. Okay, so here's another way. Either way, it totally works. I'm going to go 5a cubed over 4 times 2 over 5a. Multiply straight across the top. So we have 5 times 2 is 10a cubed. Over 4 times 5 is 20a. 20 over 10, 10 over 20 that is 1/2. So I have 1/2. I have an a cubed over the a, so subtract those, it leaves me with an a squared up top. And then you could rewrite it one more time just to make it look nice, a squared over 2, without that 1 hanging out. All right, awesome. Let's look at number 2. Go ahead and give this one a try, okay? So remember, you're just multiplying straight across the top, so I'm just going to do a big line here, and then you're going to want to factor all the ones that you can factor and just put it as one massive fraction. And then you're going to start canceling things that match top and bottom, because that's removing a factor of 1. So go ahead and hit pause, give this one a try, come back when you're ready. Okay, so for x squared plus 6x plus 9, this first one, to factor that has a leading coefficient of 1, means I can jump to my shortcut. I'm looking for two numbers that multiply to 9 but add to 6. It's going to be a plus 3 and a plus 3. This x minus 2, that I cannot factor anymore, so I'll just stick them here because we're just multiplying straight across. X squared minus, oops, I'm going to change colors here. X squared minus 4, difference of squares. So I have x plus 2 times the quantity x minus 2. And this x plus 3 I can't do anything with, so I'll just stick them here. Now we look for things that match on the top and on the bottom and start crossing them out. So I'm seeing an x minus 2 on top with an x minus 2 on bottom. And I'm also seeing an x plus 3 up top with an x plus 3 on the bottom. So that leaves me with x plus 3 over x plus 2. And remember from yesterday, don't try to do this, okay? I'm going to do it, but then I'm going to erase it. Don't do that because that is not equivalent, remember. Okay, because of this addition here, we cannot do that. If it had been multiply, if it had been x times 3 over x times 2, then you can do that. Because it's reducing, it's removing that factor of 1 because it's multiply. But again, because it's add, don't do it. All right, let's try the next one. Go ahead and give this one a try. So my leading coefficient in this first group is 1. Means I can jump to the shortcut. Two numbers that multiply to negative 2 but add to 1 are a positive 2 and a negative 1. I can't do anything with that 5 quite yet, so I'll just write them in. I also can't do anything with that 15, so I'm just going to write that in. Two x squared minus 3x plus 1. Leading coefficient is greater than 1, so that means I have to go the long way and break apart the middle term. I like to do side work just to keep it looking nice. So that means we're going to break apart that middle term. So let's see here. We want two numbers that multiply to 2 but add to negative 3. All right, I'm going to write that down. Multiply to 2 but add to that negative 3. So I'm thinking instead of negative 3x, let's go with negative 2x minus 1x, because that negative 2, negative 1 would multiply to 2 but add to negative 3. So I'm doing minus 2x minus x And you can put minus 1x if it helps you in the next step. That's totally fine. Factor by grouping. These first two, I can pull out a 2x, leaving me with x minus 1. Here I can't pull anything out in these second two, so I'm just going to put it on a negative 1 as my placeholder, x minus 1. They have that x minus 1 in common. I'll bring that out front, leaving me with 2x minus 1. So 2x squared minus 3x plus 1 is x minus 1 times 2x minus 1. Now let's start to look for things on the top that match things on the bottom. You see anything? How about that x minus 1? So we'll get rid of him. That's removing a factor of 1. Is there anything else we can reduce? How about that 5 over 15? 5 over 15 is really 1/3, right? So we have 1/3. So now what I'm left with is an x plus 2 on the top times the over 3 times the quantity 2x minus 1. And some people are tempted to go ahead and multiply that 3 out. I would say don't do that. Just leave everything totally factored. Okay, so this is good. Just stop right there, and it looks perfect. Go ahead and try both 4 and 5. Come back and hit play when you're ready. So in 4, now we've switched over to division, which remember, we want to do keep, change, flip. So I'm going to keep the first one, change my sign, and flip my second fraction. Then I'm able to multiply straight across the top to get xy over straight across the bottom. 5 times 7, I get 35. And that one's done. This next one looks a little bit different, right? Because we don't have a fraction for that first part. But remember, we could make it be a fraction, right? Let's put it over 1. So now we have x plus 2 over 1. Keep the first one. Change the sign. Flip the second fraction. Multiply straight across the top. The bottom. X minus 1. There's nothing we can cancel out. Again, some people want to start foiling this out, but since we have all things are multiplying, we do not worry about it. If it had been something like we had some crazy problem where we ended up with like a plus 2 way out here, we would want to FOIL it because it's not all multiply because of this adding, but we do not have that in this case. So here we are totally done. All right, moving right along. I think we just have 2 more for today. Yeah, let's go ahead and get those out of the way. Go ahead and try both of them, okay? So here's 6. Go ahead and give it a try. Okay, so division, so I'm going to do keep, change, flip. Keep the first one. Change the sign. Flip the second one. Now multiply straight across the top. The x plus 1, I can't do anything with that yet. X squared minus 2x plus 1, I can factor that. Leading coefficient of 1, so I jump to the shortcut. 2 numbers that multiply to 1, but add to negative 2. I'm thinking a negative 1, negative 1. On the bottom, x squared minus 1, I have a difference of squares. So it is x plus 1, x minus 1. And that last x plus 1 will fill him in here. Now we have to start looking for things that we can cancel, top and bottom, that removing a factor of 1. So I have an x plus 1. Anything else? I have an x minus 1. So our final answer is x minus 1 over x plus 1. All right. If you haven't yet, go and try this one. Remember, you can stick this fraction here over 1, or that polynomial over 1 to make it be a fraction. Go ahead and try it. Okay, so I have a squared plus 3a plus 2 over a squared plus 4. So I kept the first one, changed my sign, flip the second one. Multiply straight across the top, straight across the bottom. Let's go ahead and factor at the same time, just to do a little bit less writing. Okay, so up top, leading coefficient is 1, so I can jump to the shortcut. Two numbers that multiply to 2, but add to 3. Positive 2, positive 1. Just times that 1, so we don't need to worry about that. How about the a squared plus 4? Can we do anything with that? A lot of people see that a squared and the 4, and they do the difference of squares. But remember, difference means subtract, and here we have add. There's no sum of squares rule that we know, okay? So we're just going to go ahead and just write in a squared plus 4. We can't do anything with him. Now 5a squared plus 10a, what can we factor out of there? Get a 5a out of that, right? So 5a, leaving me with a plus 2. Now we'll start looking for things that cancel top and bottom. I see an a plus 2 on the top and on the bottom. I don't see anything else that can cancel out. So a plus 1 up top. And it just kind of looks prettier if you put that 5a way out front. So I'm going to do 5a with an a squared plus 4. All right, awesome job again today. Tomorrow we're going to start looking at adding these together, okay? So today we did multiply and divide. Tomorrow we will look at adding them. Great job. I hope you have an awesome day.